Hi. Thank you for coming. It's a small room, so just kind of go in there.
You don't have to get people to
squish.
It's easier for people to find a seat.
Yeah. We'll just give it like a minute more to allow people to get in. Yeah, no, go ahead. Okay. Yeah. Okay, let's go. So, today we're going to talk about reading other people's code. Just short about me, I'm a programmer, mostly C++ for the last 15 years. Also Java along the way, and other languages like Python, JavaScript. But let's just get down to it. So we're going to break the talk up in four sections. So you got somebody else's code before you start, 10 techniques, and the last one is receiving a new contributor. But let's just get started. So you got somebody else's code. Now, if you look at her, she's not very happy. And this is generally the attitude you get when you get dumped somebody else's code in your lap and you kind of have to figure it out on your own. Most people are not happy. This is like the opposite of a greenfield project. This is somebody else's very, very well-trodden field. But the most important slide, I think, in the whole presentation, if you're going to get down to it and how you're going to be successful in dealing with somebody else's code, is to realize that this is not a code review. Because if you approach somebody's code wanting to learn, then you will learn. If you approach it to criticize, you will actually only criticize. It's very, very hard. And you can see this often also online, where if you're on Twitter, somebody tweets an article, and then somebody who's only read the ingress says, I disagree totally. People have a tendency to stop the moment they find something they don't like, and then comment on that and be annoyed by that and not actually finish. So if you really want to understand and contribute and change somebody else's code, you have to put that aside. And you have to go into it as a learning thing. I'm going to understand it. I'm going to try to understand what this person meant to do, what this code is trying to do, or what kind of plans somebody had that kind of got abandoned. So instead of condemning people, let's try to understand them. Let's try to figure out why they do what they do. That's a lot more profitable and intriguing than criticism. And it breeds sympathy, tolerance, and kindness. And this is from a very, very old book. The book is actually, well, very old. It's from like 30s, 40s. It's like the start of all of these self-help books. It's by Dale Carnegie, and it's called How to Win Friends and Influence People. And if you ask most people in leadership and tech, this is probably one of the top 10 books they point to. And the reason for it, it is very friendly for people who are not very socially skilled to actually sit down and learn how to talk to people. One of the sections is that you should smile to them. People like that. And that's the point here as well. Because if you're looking at reading somebody else's code, there is a reason why you're reading the code. Either you're new in a team and you're trying to get into the code, or you have this open source project and you want to start contributing to that because you think it's really cool. The point is, you want these other people to like you. So the worst thing you can do is have your first pull request be a refactoring of their code. Because as much as we would like to say that refactoring makes things better, one thing is for sure, you would not have submitted that pull request if you didn't think that your version was better than theirs. There is an implied criticism in submitting a refactoring. Now, this is how I think about code. That you have this mental machine in your head how you think things should work. You get your input, you do this thing, then you write maybe to some files, send something on the internet. You kind of have this idea. You know how to manipulate it. When you get an input, certain parts start moving to other places. And you have this idea on how that works. When you change it, you kind of change in that mental machine. But to actually code, you have to serialize that model into text files on disk. And these text files don't really model this mental machine. You are generally jumping from place to place, from file to file. And you can see that if you debug and you step, you're kind of jumping from file to file. Which means that when you are reading somebody else's code, you don't have their mental model. You don't know what the machine looks like. All you have are all of the files. And that's the problem. Because when you have your own code, you think my code is very readable and understandable. But your code, you have the advantage of having the mental machine. And you can see this very often if you are in actual code reviews, is that it's much easier to review functionality in code you have written yourself. So let's say that you're reviewing a patch, and it's in something you wrote yourself. Then you might have comments on style, because we have a tendency to like that. But you will also say stuff like, OK, but this is not going to work because you have this constraint over there, so that's going to break this. And you're going to actually explain why this won't work. The moment you're starting to review somebody else's code and patches in that, you have lost all context. You don't have a mental machine anymore. And now you're basically sitting down going, I can comment on style, I can comment on programming, I can comment on general things, but I can't really tell you that this won't work because I don't have a mental machine for this code. So because running code is not linear, then reading code can't be linear either. And also, most of all, because it doesn't scale. We often think, like, when you go to school, they go like, OK, well, you can print out the code and sit down and read it and bring your pen and paper and you outline it and draw and whatnot. But the thing is, I've worked on really big code bases. I worked at Opera. We made the Opera browser. I worked in embedded sector where I worked a lot with Android. And I worked in Vivaldi, working on the Vivaldi browser, which is Chromium-based. Vivaldi has, with Chromium and everything included, 600,000 files. You can't print it and read it in your chair. There is no way that this scales. And not only that, you're not, like, you have 600,000 files and you want to change one button. Okay, so you need some way to even find the code that has to do with the functionality that you want to alter or the functionality that you want to learn. You actually have to find it first. So I'm going to show you some things that I usually do before I get started. And then I'm going to show 10 techniques that I use for trying to understand. So before you get started, or actually getting started, and I say getting started because often you have this, this kind of resistance towards starting because it seems very overwhelming. And you're looking at this and it's like all of this code, all of this file structure, I don't even understand the file structure. You kind of cloned it and you have it there and you kind of feel like I want to go and have a coffee or lunch or a shower or walk or basically talk to somebody. So this is steps just to get going also. So first, get the code. Some people think that you can do this by just like reading the code on Google, but it's very, very hard to get any place further if you don't have the code locally on your machine. So get the code, clone the repo, do whatever you need to get the code locally, and then get it into source control. And the reason why it might not be in source control, this depends. This might be a legacy system. It might be a system that's in a source control system, but not yours, so you don't have access to it. So get it into Git if you can, if it doesn't have anything. Because the reason why you want that is you're probably going to make changes, and you want to revert those changes. You're going to be adding probably printfs everywhere when you're trying to run it, or that's if you're a C code or any kind of system out print line Java. What is the C# way of like just logging something? No?
Console.writeLine.
There you go. Console.writeLine everywhere, right? But at a certain point, this gets too noisy. You know what's not applicable, what is applicable, and then you just want to remove all the noise. And that's, if you have it in Git, then you can just do a git reset hard, and you're off again. And you might actually break something too, so it's nice to be able to roll back. Get it into a smart IDE, as smart as you can afford, because you can use the IDE for many things. And then you want to build it. And you want to build it because you want to run it. Because if you can run it, suddenly you have other tools available for you. One, you can actually see it, and you can make changes and see what happens. But you also have access to the debugger. You also have access to logs, which would be nice. And that's why you want to put it in a debugger. But I would also say try to run the tests. Because if you have tests, then you can also make tests. And making tests is a way to drive execution in the code that you're looking at. So let's say that you're looking at a specific little class that has a specific behavior that you want to change. Maybe there's a bug there, right, that your project has. And so you want to drive that little code over and over again. And if you're going to drive it through your own application, you have to click through 50 dialogues and then 4 buttons and then type in a name and press OK before you actually get there. So it's very annoying. So if you can put that specific code in a test, then you can run it quickly. You just press play, and then you can iterate more rapidly. So, but why are you doing this? Because now I'm already saying possible ways of why you're doing this. One, you might want to just learn something. You might have a code base in front of you that you want to learn. And that could be because you're in a new job, right? But it could also be that it is, you just think this framework is really cool and you want to contribute to it because you want to be cool. But you might also want to make documentation. You're thinking, because documentation is also a very good way of making people like you. If your first commit is documentation, people will like you. Because everybody feels, oh yeah, our documentation isn't really good. And the good thing that you have, if you're new in a code base, is that you can contribute to the start documentation, the like new in project documentation, which is the most important documentation for getting new contributors, right? But you can also teach others. So having a presentation at your workplace, having a presentation at a conference, you might go, this is how this thing works. And teaching is also a very good way of learning because you have to have a deeper understanding. And the reason why I say motivation is because you can just choose something. You might have to do something for your work, but you can choose some other motivation that motivates you better. So you might say, okay, your actual goal is to fix this bug, but I also want to present about this at a conference. And that might be more inspirational to you. So if you think about all of these files, they're basically just randomly, like people, well, they're probably not randomly. People hopefully group things in sensible order, but that's not guaranteed. And so basically you have all of these balls of yarn on the floor. And I think about yarn because you have code execution. It has a tendency to jump around. So you have all of these code executions lying on the floor, and you don't know which one is important to you. It's a mess. So what you do is you just find an end, something that looks interesting somewhere, and then you just pull on it. And then you just follow it to wherever it goes. And I'll show you ways to do that. So the way you work through this is you basically, this is an iterative process, right? So you establish like a vague outline, I think something like this. And you might draw it or something. And then as you iterate through this, you will flesh it out, and suddenly you will understand something you didn't understand in the beginning. You will like, oh yeah, that's why they do this thing over there. That was weird. Okay, now I understand. And this fleshing out is better if you have notes or drawings or something, because you're going to forget what you looked at like 3 days ago. But then, you know, when you are like 3 days in, you go like, oh, wait a second, let's go back to the beginning. And you'll be like, ah, okay, that's how it is. So having notes drawings will help. Okay, so 10 techniques for reading code. I'm going to list them first, and I'm going to go through them in detail. So the first one is grepping. And I want to say grepping first because grepping is probably the most used one and the one that we are most ashamed of. So I'll get more into it. Then where is this button? Following input events. What do the tests do? Refactoring, reading main, the graphical layout, runtime investigation, reading a class, and retelling or rubber ducking. Okay, so let's start with grepping. Grep for strings you can see. This is a really good way to start. And actually, the funny thing is this is mostly how people start. Because you're basically faced with all of these files, you don't know what they do, you have a running application over here, and you're trying to figure out how does this code map to this application. So you can grep for a string you see in the UI someplace, in a dialog, a label or something, and then you figure out where in the code that label is, and then trying to figure, okay, so this is the code that has to do with this dialog over there. You can grep for things you see on the command line. So if this is a command line tool, you can figure out which command line switch you're interested in and grep for that, and then follow execution from there to actually find the code that has to do with what you're interested in. But most likely, you're looking at your own logs. Because the biggest reason, in my experience, that people are reading somebody else's code is because they have a bug in one of their frameworks. Or they think they might have a bug in one of their frameworks. So you have something in your log of your own application, something is going wrong. You have an exception or something, and you don't know what it is. So what you can do is then find your error and then grep in your frameworks to find that error and then trace what happened to produce this error. And then you might actually find out that you called an API wrong, and then you fix your own code, or you might find a bug in this framework, and now you can upstream it, and this is a good way of gaining goodwill because you're actually fixing bugs. So one way of doing the grepping is where is this button? So you start with the grepping. You grep for the button text. And this is, again, it goes for any kind of UI element that you can actually have a string or something that's greppable. So you grep for the button text, and then you find the button definition somewhere in the code base. And then around the button definition, you will generally find some kind of on-click handler. And this is where you really, really want to have it in a debugger, because now you can set a breakpoint on the handler, and then you click the button. And this is great because now, instead of having just files and just a running application, you suddenly have the data structure and everything of the application frozen in your debugger, and you can actually move around and look at stuff. And some of the things that you can look at is the stack, like how does this thing get this click? Like, what does it move through? And there you will often find a lot of the control logic for your UI. You can traverse up the widget hierarchy and figure out how the widget hierarchy is structured and how the UI is structured. So there's a lot of things that you can learn about an application by just looking at stuff in your debugger. And then you have the opposite end, following input events. And this is where you are actually looking at a UI framework. And a UI framework has certain characteristics that you can use to look at them. And one of those is tracing platform events. So on your platform, you get your mouse events, you get your key events, all sorts of like low-level events, and they go into your application somewhere. And very quickly, if you're using a UI framework, they're going to be hitting your UI framework. And the reason for that is that UI framework needs to figure out who is going to get this event. Like, it has to figure out what is the mouse position, what is the widget underneath, who should get this event. And the reason why you want to look at this and you want to look at the graphics output is because those are the two main functions, low-level functions of a UI framework. They have to deliver input events, and they have to deliver the final UI frame. Those are two ways that they're going to interact with your operating system. And so that is two ways that you can find the inputs and outputs of this framework, and then you will find the core code in a UI framework. Because UI frameworks are massive. Like 90% of the code is going to be finely tuning different types of UI widgets. Going to be about how are you going to specify the curvature of a corner of a button. There's going to be tons of code for that. But what you're looking at is finding the central classes, the actual core code, because you can't read everything. So now we're trying to narrow the scope. And this is where you will find the platform integration. And that is the core part of the UI framework. Next one is, what do the tests do? And when I talk about tests, I'm not talking about unit tests. Because if we're looking at a code base, unit tests are too fine-grained. Unit tests are at unit level. They're generally at a function level. And you don't even know what class you're looking at. You might not even know what module you're looking for. So looking at unit tests are not going to help you. The unit tests will be awesome if you make a change, because they might actually catch if you did something wrong. But at the code investigation level, unit tests are kind of useless. What is really useful is integration/system tests. Because these show different things. They show how do you exercise this application? How do you get it up and running? What kind of input does it take? How can I manipulate it? What are the interfaces that it has? Suddenly you might find out that this application that you thought was a UI thing that you had to start up and click buttons, oh no, it takes command line arguments, or it can actually be configured through files. And there are lots of things like that that you will learn by looking at integration/system tests. And this is also a good reason why you should have these kinds of things, is because they document your interfaces. So you know how to run it, and you know use cases. Because very often the system tests have like nice names, like open a file or add new user. They have actual descriptive names that map more to use cases. And you can also use them to drive execution. So again, like I said, you want to try to exercise your specific code path. And you go like, OK, so I want to add a new user, but I want the user to have a Chinese name. Because this is how my code is failing, with a Chinese name. And then you might set up a specific test to do that specific thing and exercise your specific use case. And then you can also write tests to test your own assumptions. You go like, oh, OK, this is how that works. And be like, oh, OK, I'll just write a test and assert all the things that I think are true and see if they are actually true. And then we come to the most dangerous one. And that is refactoring. But we have to talk about refactoring because you're going to do it, and you should do it. The one thing that is important about refactoring is that it is opinionated. It is very opinionated. And there's no way to get around the fact that refactoring is opinionated. And so you have to do a temporary refactoring. That means do refactoring to understand, but don't get attached to it, because tomorrow you're going to do a git reset hard. This is not something you will ever show anyone. And having to do refactoring as a learning process, not as something producing an output. You are not going to give this refactoring to anyone, but you're refactoring to understand. So this is throwaway code. And you have to get into that mindset before you begin, because people have a tendency to get extremely attached to their refactorings and very opinionated about them, saying, yes, but my thing is so much better than your thing. So you have to go in with that mindset that I'm going to do refactoring as I learn, I'm going to try new things and blah, blah, blah. But I'm doing this as a learning exercise. So then we come to reading main. And I put main in quotation marks because it doesn't have to be anything like main. It has to be whatever drives execution in the code that you're looking at. So some kind of central function that drives the execution in the thing that you're looking at. So when you get to reading main, you have most likely either reduced your scope or decided to start at the beginning, at the actual main. So what you're trying when finding main, you're looking for what is the thing that drives execution. But when you get there, you will have, if you're in the actual main, then you will often have some kind of main loop or event handling if you have an asynchronous application. If you have a synchronous application, main might be very simple. You know, you do A, you do B, you do C, and you're done. But in a more complex asynchronous application, you will generally have some kind of main loop. Now, if you're running in a UI framework, you might not even know you have a main loop. If you have any things like callbacks where you do on something, you have a main loop, you just don't see it. Then the main loop is inside of a UI framework. Yeah, and this is code that you want to actually read from top to bottom. So up until now, I say jump around. But this is something where you want to read it sequentially, because this generally is a sequential thing. You have to do A, you have to do B, you have to do C. And take notes and draw like you always do, but now you're doing it at a much more detailed code level, right? You're not doing it at an architecture level, you're doing it at a very concrete level. And you might see important objects being passed around. Like you might have a class like called control or something that keeps on being passed to objects all the time. So this might be a very important class that you need to look at, because it might have important data structures that everybody needs to share. So this is a way of figuring out what are like important other things you need to look at. Yeah, and look for common types, like things that keeps on being used. They might be also very interesting. And this is a recursive process, because most likely people want to abstract things. And so you might actually have a main that has like 3 lines. That says do A, do B, do C. But you might have to go and look into those again. So if you are looking at a UI application, then and now we're talking about the application itself, then in addition, we looked at finding a button, but we want to figure out how does the application as a whole work? What is the core? Like the same way we found the core of the UI framework, we're now looking at the core of a UI application. And that you will often find around the graphical layout. And when I talk about the graphical layout, it's the window layout, the layout of all of the widgets. And the main layout is what changes the window contents. And now we're talking about in a very high level. So imagine, for example, if you go to Gmail. First time you go to Gmail, you have to log in. Okay, so when you have to make a user. And then after you made a user, you have to log in, or maybe you do both in one. The first window you get to is the messages list, your emails, right? And then if you click on create new email, you might come to a new thing. Currently, I think it's actually like a dialogue-y thing, but imagine you get to a whole new like create email like you did before. And or you can have like searching for things or going into contacts or many different things. And what you see by those things is that they often map to actual use cases. Like you can explain what this thing is, like create email, search emails, or add like log in. They generally map to very high level concepts. And the other thing that you will see is they have a tendency to change the entire window. So instead of having like, okay, you have a transition which changes a button to be disabled, for example, that's a very minor change. But in these big state changes, you're changing the whole window to look totally different than it did before. And where you find the code where these transitions are, from being not logged in, view email, these things, these transitions between these states, you will find what is often an implicit state machine. And if you find like the people who worked on the projects for 10 years, they can draw it for you. They know exactly how it is. Now, if you are in this state and you do this thing, then you go to this other state. But if you click the logout button, then you go back to the other state. And they can draw this high-level thing. But there is code somewhere that actually has this state machine. And the reason why it's implicit is because very often when people make a UI application for the first or the second time, they don't realize they need a state machine. And so this might actually be lots of ifs, like if logged in and send mail. And but if you've done UI applications like 3 or 4 times, suddenly you have an actual explicit state machine where if you're in state A and event B happens, then you move to state C. They actually start making explicit state machines. OK, so then you have runtime investigation, because we talked a little bit about being in the debugger and a lot about reading code and grepping and jumping around. But what more can you do? Runtime. And this is an awesome drawing. Sorry. OK. So during runtime, and this will often depend on what kind of application you have. So if you have a synchronous application, then you're going to love your debugger. And this is something that you will see if you ask people how they debug. Especially, let's say, how many of the people here have like a front-end, back-end kind of architecture? Yeah. OK, if you work on the back-end, you probably love your debugger. It's like, I don't know how I could work without my debugger. If you're working on the front-end, you'll probably hear it there in the and there's a good reason for that, because a back end is mostly synchronous. And people are like, no, I have lots of threads. Yeah, but each thread is mostly synchronous. Each thread is, I get this request, I'm going to do this thing, and when I'm done with the thing, I'm going to send my response. Between the request and this response, things are mostly synchronous. And if you do some asynchronous stuff, they still have to get back together. Or it has to be a fire and forget, because we have to finish. There's like a deadline here. And so because it is highly synchronous, the debugger is awesome. You kind of just set a breakpoint at the beginning, and then you can just step through the whole thing. It's awesome. However, if you're front end, you're the exact opposite. Your code is highly asynchronous. It's basically just callbacks all the time. You're basically, I'm doing an event, and then I have a callback. When it's finished, it's going to come back. It's extremely hard to debug with a debugger, because you start stepping, and then you're like, OK, poof. I fired something to the back end. OK, I have to set a breakpoint when it comes back. And so you have to send multiple breakpoints in many, many different places. And how you do the debugging with the debugger is basically you jumping from breakpoint to breakpoint. And that at some point you didn't hit any of your breakpoints, and it's like, woohoo, what happened? I don't know what happened. I need more breakpoints. And so basically you're just adding breakpoints everywhere, trying to figure out where you end up. It's a much more messy process, and it's not very comfortable. So what you often see in asynchronous applications is that they will do a combination of lots of logging and breakpoints. So they will add lots of logging, if there isn't enough already, run through their scenario, figure out which log messages actually come out, and then they'll set their breakpoints there. And then they'll just start, and then it will jump to the correct locations. But again, it's a totally different way of working. And it also often means that if you have front-end and back-end people talking, they will have this very different understanding of how this process works. And there you have like the classic printf debugging is something that, and printf debugging is basically only logging. You're only looking at your logs. You're not using your debugger. And this is something that you might have to do if you have something that has the real-time constraints of some sort, that if you break, actually things will fail because you missed a deadline or something, so you can't actually stop it. Or if you have something that only happens, let's say that you're processing video frames and it only happens on the 1,000th frame or something. There's no, you can't step through it, all of the 1,000. You kind of have to say, OK, if I end in this error over here, what was the state of things? And then you have the use of a profiler. And I put it in parentheses, but it is quite useful in trying to figure out like how is memory allocated? Like which part of my application allocates all of my memory? Which part of my application takes 90% of the time? You might actually find a lot of core code looking at it that way. So you have this highly asynchronous stuff, which is event-driven architectures. Then you have this request handling thing that we talked about, so more like a backend type of system. But you also have things like a command line tool. A command line tool is even easier than like execution-wise because it has all of the characteristics of one single thread in a request type architecture. You have a main, you start at the beginning, it has to end. There is a certain limit to it. Yeah. So you use the debugger to examine both the state. So if you stop at a breakpoint, it's interesting also to examine the state of all of the things around. Because you might actually, you stop at a certain point and I was like, I want to know what the state of the UI is when I hit this thing. But also the stacks will tell you how you're getting your events, how you got to this place. Maybe you're saying like, I should not be here. How did I get here? What actually triggered this? What kind of code did my calling application call for this thing to happen? And you can read the logs to see the flow, and you can use the test to drive the flow. So you have the specific flow that you want to do, and after looking at it in a debugger and looking at the logs, then you're setting up your test to do that thing so that you can do it over and over again until you figure it out. So you add stuff. And the last one is kind of interesting. If you are in a new job and you have to learn the code base at your new job, I really recommend adding like a throwaway feature, like a button next to one of the buttons that does a stupid thing. Send an email to my boss or something. And the reason for that is that you might think you understand how things work, but you only truly understand how things work when you have to make a change. So let's say that you boiled it down to, okay, this class. This is the thing that I have to look at. It actually goes a lot back to what we said before, finding what are the interfaces. How do other things around look at this thing? Who uses it and how? Very often you would start by looking at all of the public methods and then you'll think, oh yeah, I know the public interface. But often a lot of stuff is public that nobody actually calls. Might be public for historical reasons, might be public because you wanted it in a test, whatever. So looking at, and this is a good way to use your debugger or your IDE to look at get usages of this class. And then you can look any place that people use this class and figure out how they use it. So if you found your public functions that are the ones that are being called by calling code, then these become mains. And you do them the same way you would do a main. You read them from top to bottom, you make notes, you go deep on these things. And getters don't count, of course. Okay, so we're in our final one. Retelling or rubber ducking. So how many people have heard about rubber ducking? Okay, a bunch. But still a bunch that has it. Okay, rubber ducking is basically the idea, and the thing is most of you have done this, you just might not have a name for it. And that is you try to explain your problem, and by explaining it, you suddenly understand it. And the thing is, the idea is to do this in a very unsocial way, so you're trying to do it to a rubber duck. So the rubber duck is what you're explaining it to, see? In my experience, rubber ducks are really bad motivators for actually sitting down and talking to them, and it looks really weird in an open landscape, you know, there's a woohoo. So I would actually go for more retelling. And retelling most people have done. Like you walk into some other person that's used to this code, you walk into their office or, you know, their desk if you're in open landscape and go like, okay, I have this thing, I don't understand, I've done everything, blah, 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 and they'll go like, okay, slow down. Start from the beginning. And they'll go like, okay, so I did blah, and I did blah, and I, never mind. And then you just walk away. This is retelling. This is by being, and again, it comes again to the serialization process. You have a mental model, you have like things, but they're kind of like loosely coupled inside of your head. When you explain it to someone, you actually have to serialize it into a narrative that makes sense. Instead of being this vague thing in your head, now you actually have to structure it. And as you structure it, as it comes out of your mouth, you suddenly realize where you're weak, what you didn't understand, or where you misunderstood something. So explain it to someone. try, if you're looking at some code and you think you got it, then go to somebody and say, okay, I've been looking at this code. Okay, can I just explain it to you? Go up to a whiteboard and try to draw it out. They will ask you questions and you will go like, I don't know, but I will look into that. You can write a fictional blog post or actual blog post. Like actually doing that, being able again to structure it in text is a good way of actually realizing whether or not you understood it and dig deeper in the things that you didn't understand. Write some documentation. One thing that a lot of people told me is that they write questions to Stack Overflow and then they delete them. Yeah? Okay, a lot of people do this. It's not only you. I've talked to some people who are really like write a lot on Stack Overflow and they will say something like 8 out of 10 times they delete the question. And the reason why is as they're trying to formulate the question properly and structure everything, then they realize what the answer was, and they never actually submit it. Somebody I talked to said that she writes an email to someone that is really good, and she will write all of the things out in the email, and if she still doesn't understand it by the end of like the email, and this is to a respected colleague, so you don't just like send something randomly, you're like, I want to make sure I'm not making a fool out of myself right now. And then she says also, 8 out of 10 times, she just deletes the email. Because by the end, she knows exactly what the problem is. You can make an internal presentation at your workplace. But in my experience, ducks are not very motivating. I know a lot of people have rubber ducks on their desks, but I don't think they actually use them. So you are probably already rubber ducking, not realizing it, by just talking to people. The most important thing that you have to understand is all of these techniques are just snapshots of different things. And you kind of have to jump around between things. Because what you're trying to build is not something that's linear. You're trying to build this mental machine. You're in your head, somebody else's mental machine, you are building in your own mind. And so this is going to be messy. You will have like maps in the old days where you have like a white section on the map and it'll be like, here be dragons. Your mental machines will be full of here be dragons. You have no idea. You'll get us like, okay, I kind of understand this thing up here a little bit. I don't really understand anything else. So it being an iterative process means you can refine things. You understand things more deeply as you do more things. So again, like I said before, you establish a vague outline, you do an iterative process, you take notes, and you draw things out. And that's the 10 techniques. Now we come to the other side of this. Because until now, we were the contributor. We were the people who were trying to learn. But how do you deal with receiving somebody into your project who is new, who do not understand the code, who are trying to learn? And there's some very interesting research done around the concept of excellence. So Google had a research project called Project Aristotle. How many have heard of Project Aristotle? Awesome. Okay. Because Project Aristotle was super interesting. They were looking at what was the predictor of team excellence. They wanted to try to figure out what they could do to optimize for team excellence. So they went and they studied their own teams, trying to figure out why one team was better in some way than another team. And they did this for years. And they had lots of theories, lots of hypotheses. They tested it again and again, but the data did not support the hypotheses. They thought things like, okay, if all of the people in the team are brilliant, then the team will be brilliant. They thought all of these things, and the data didn't support it. And so they went back and they tried to dig more into these teams. What was up with these teams that were great? Because it wasn't because they had great teams that only maybe had a couple of people who were brilliant, and the rest were kind of average. But for some reason, they were doing fabulously. And what they concluded was a term from a report from a totally different discipline. It was from healthcare, I think. And it talked about psychological safety. And what they found was that the predictor of team excellence was that people felt safe to say everything that they had on their minds. People were not afraid to say, I don't understand this thing over here. They weren't afraid to say, I wonder if like this thing over here, that's kind of, I don't know what to do about that. Or come with suggestions. If somebody says, okay, does anybody else have a solution? You might have an idea for a solution, but you don't want to say it because if you say something, somebody's going to jump on you. And what you end up, if you are in a team with that kind of culture, of massive criticism, and you think, oh yeah, but we're doing this because we want to make sure everything is excellent. But what you're actually doing is making people hold back. And you're only getting a fraction of what they can produce because they're too afraid to say what's on their minds. And this is the work on psychological safety is from this woman called Amy Edmondson. And it's from this report, Psychological Safety and Learning Behavior in Work. And what she says, the term is meant to suggest neither a careless sense of permissiveness nor an unrelenting positive effect. So it's not, the point isn't to say, oh, everybody has to be so nice to each other all the time. You can never say something bad. No, that's not the point. It's a sense of confidence that the team will not embarrass, reject, or punish someone for speaking up. This confidence stems from mutual respect and trust among team members. That I can say a thing and nobody will say, you're stupid. They will go like, okay, I didn't understand it that way. I understood it a different way. Or they will say, okay, yeah, I thought that way last week too, but when I tried it, it didn't work out. People can actually have like normal conversations. And she established this matrix, which is kind of interesting when you want to talk about this. And the idea is on the y-axis, you have psychological safety from low to high. And on the x-axis, you have motivation and accountability. And one thing is from tech, because she has done these studies in many different sectors, especially in healthcare. And what you see in tech is that we're generally highly motivated people. We really want to do a good job. On average, we're ridiculously motivated for our jobs. If you compare us, for example, to people who wash dishes in cafeterias, not so much. You know? They do it for the money, but it's not like they would do it for fun. It's not like somebody will go and ask them if they're doing dishes in the evenings or have hobby dishwashing projects. We are generally highly motivated people. We think what we do on average is interesting. But if you look at people who are low in motivation and low in psychological safety, there you often find this group apathy, is I don't care. I don't feel that what I'm doing is important, and nobody cares about me, so I don't care. And I'm going to do the minimum amount of work that I can do to still get paid. But it's not something I care about. I don't care about the quality. I don't really care about anything. I just get through the day. If you have a job that isn't really interesting, but people are really nice here, then you come to comfort. It's like you don't really feel that it's very interesting what you do, but you have really nice colleagues. It's a nice workplace. You enjoy the people. You know, it's all right. But we're generally in the high motivation. And if you have high motivation, you really want to do a good job, but everybody is mean to you at work, this is when you cry in your car in the parking lot outside of your window, of your workplace. This is where you go home and you cry. This is where you go home and you don't do anything because you just have to like rebuild yourself so you can do the same thing tomorrow. You really want to do a good job, but you're miserable. But if you can get to high motivation and high psychological safety, then you're getting to a learning mode. You want to improve. You want to get even better. You want to help your colleagues be better. You want to make the thing that you make together better. It becomes a thing that rebuilds on itself, where you want to help your colleague to step up their game, because then we can do even more amazing stuff. You want to bring in new people and make other things and learn things and go to conferences and all sorts of things. The thing is that what most people in management are afraid of is that they will end up with people either in comfort or apathy. They are afraid that I'm going to bring in people and I don't care. But this is not, in general, a problem we have in tech. People generally care. So what we end up with in these highly competitive environments which we create, we end up with people just being anxious at work. It's like I spoke to a woman. She said that whenever I submit a pull request, everybody just kind of jumps on it and says all sorts of mean things to me. And she was like, okay, so I was thinking maybe I was really bad, but then I went and I looked at their code, and their code is much worse than mine. And I'm like, yeah, but what do their pull requests look like? And she was like, because nobody's going to say anything to them. One of the things that we don't realize is that peer review processes are used as workplace bullying instruments. People who are in marginalized groups regularly get harassed in your code review tools. And you might not even realize, because it's all disguised in seemingly rational criticism. But what you will see is the amount of criticism is totally disproportionate. And you will have a woman submitting a pull request getting 100 comments, and you will have a guy submitting a pull request getting 1. So this is something that you have to keep in mind, because code review processes are quite dangerous because they affect your career. They affect your relationship with your boss. Because your boss says, yeah, but what have you actually produced? And you're going like, yeah, okay, I have made 15 pull requests, but none of them are being accepted. And be like, yeah, it's because you suck. People lose their jobs over these things because what it seems like is that they are being incompetent, but actually they are in a toxic environment. So what we want to do is to get into a learning mode. We want to support each other. We want to get the best out of everybody in the room. And that means we have to tone down this very aggressive style. And then people say, yeah, but you shouldn't take things so personally. It's like, it's just criticism. It's the code I'm criticizing. I'm not criticizing you. That's not true. And you all know it's not true. I don't know why we keep saying things that are not true. Great code should be personal. You want people to take pride in their work. Style is individual. And the thing is, and again, back to what I talked about before, we have a tendency to criticize style all the time. And the reason why we criticize style all the time is that these code review tools give us patches. They give us diffs of very small pieces of code in code that we don't know. And some people think that's a feature. They'll go like, no, we don't do the peer reviews inside of the team. We get another team to do that. It's like, yeah, okay, so now you lost all of the functional feedback. Now you're only on style. So that's great. Now we can just scream about curly brackets and spaces. And we're like, no, we have a tool that fixes that. Learn to appreciate other people's code. And this is like, I'm not even saying like, I told you not to criticize, I wanted to put your ego aside, blah, 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 get into learning mode. This is like going all the way over the other end. But once when I was at Opera, I had to make a class in like a part of the code that one guy had written a few years ago. And I really liked his style. It's totally different from mine, super minimalistic. He had like, no function had more than 4 lines. And it was all like very small. It was just, I don't know, it was really nice. It was very, I don't know. It's, yeah, minimalistic is the only name I have for it. And I was coming from a Java background, so I was like, woohoo, look at me. I have all of these things. And so I wrote the class in his style. I mimicked his coding style when I wrote the class. And then I came to it, and I printed it out on actual pieces of paper, this class that I've written. And then I took it to him, and I gave it to him. And I was like, what do you think? And he was like going through, yeah, it looks good. I'm like, nothing? I'm like, no? I don't know what you're talking about. Well, does it remind you of someone? And he was like, it looks like mine. It's like, I never wrote like that again, but I really respected his style. And getting into that, to appreciate that somebody else's style could be good, even if it's not like yours. And and you can find pieces of things that they do and mimic those, because it's like, oh, I like that. I want to do that thing over there, even though nah, it's not my thing, but this thing is really cool. And the photos from my whole presentation, and always, are from pixabay.com, and that is my talk. Thank you.